This is Sean of Math Swap Tutoring, and in this video, I want to talk about first and second derivatives of parametric functions. Okay, so let's go ahead and get right into it. So first of all, x equals f of t and y equals g of t represent two functions, um, x and y, that are, functions of t. Okay. Now, x and y are related in the following manner. Y equals f of x. This describes the relationship between x and y. Y is a function of x. Okay. Now, if we wanted to, and this is your parametric function. So if we want to take the derivative of this function, um, first of all, remember y and x are functions of t, as we said here. So first thing I'm going to do is kind of rewrite these, um, just so that we can be remembering that these are functions of time. Y of t equals f of x of t. Just another way of writing these two, but accounting for the fact that they're individually functions of time. If we take the derivative of y of t, that's going to be dy dt, derivative of y with respect to time, or not time, but t. um, could be time, but anyhow, equals. Then we take the derivative of the other side, which we use a chain rule for. So that's going to be, and I'll write it this way: d of f of x of t. So the derivative of that with respect to x times the derivative of the inside, which would be dx dt. Okay. Now, finally, we're going to rearrange by solving for this. Keep in mind that y equals f of x. So I'm going to change this d of f x of t over dx. I'm going to change that to dy dx. Well, let me just do it this way. I'll just write it as is. So d f of x of t dt. I mean dx. I'm sorry about that. Where's the pen? Okay, here we go. Is going to be equal to dy dt over dx dt. So in other words, the derivative of the function f of x, is going to be equal to, with respect to time, is going to be equal to dy dt over dx dt. Now I'm going to rewrite this. So dy dx equals dy dt over dx dt. These are the same thing. Why? Because y is equal to f of x. So that's why I replace f of x with y. So the derivative of y with respect to x is the same as the derivative of y with respect to t over the derivative of x with respect to t. This is the first derivative. And we can use this to find slope. Okay. And let me put some color around here so that can be easily seen. Now, if we want to find a second derivative, this is how we do. So what happens is, so d squared y over dx squared. So we're taking the second derivative of the of this function. That is taking d dx now of the first derivative, right? So now, in place of y, and let me use some other colors here. So in place of y, now what ends up happening is when we take the second derivative, we're essentially taking the derivative of dy dx. So y gets replaced with dy dx. And so that is equal to d dt of dy dx over dx dt. Now, and let me underline this and underline this. So basically, all that we did was we replaced the y here and here with dy dx. So ddx of y in the first derivative. Let's go back to the first derivative here. So ddx of y is equal to ddt of y over dx dt. So then when you take the second derivative, ddx of dy dx is equal to ddt of dy dx. All we had to do in both of these instances was replace y with dy dx. So it's equal to ddt of dy dx over dx dt. Okay. And so this is the second derivative, which we can use to determine concavity. If it's, concave up or concave down. Okay. Now, hopefully this is helpful. I recorded this for um, the purpose of reviewing and trying to remember, get a better understanding myself. But let me know if this is actually helpful or if I can explain something a little bit further. Thank you for watching and hope that you have a great day. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.